equation. So the second chemical property is reaction with the metals. So when it is react with the metals, we can see sodium acetate plus hydrogen gas. Next, if it will react with the potassium, for example. So potassium, if it will react, so we'll get it potassium acetate. That is what CH3COOK. Plus again we'll get hydrogen gas. This is what we used to call it as a potassium acetate. Remember, here also there is a 3 tests to identifying the acetic acid. Every test is very, very important. And this is only the test we are going to study now. So next one, CH3COOH reacting with the calcium. So by the time we will get it, CH3COO twice Ca plus hydrogen gas. So name of this one is calcium acetate. Calcium acetate. This is what is the examples of reaction with the metals. Next one, reaction with the bases. So we all know that acid will react with the base. That is a reaction we used to call something. Anybody can tell? Reaction with the bases. Acid react with the base. What is the equation we used to say? Everybody.
Neutralization reaction.
Yeah.
Neutralization.
Neutralization reaction. Okay. So that is what it is. So what is that, everybody? So example you can take. So CH3COOH, acetic acid is reacting with the sodium hydroxide. So what will happen, everybody? Weak acid reacting with a strong base. So we'll get basic salt or acetic salt. Basic salt or acidic salt, everybody. Basic salt plus we are going to get water. So this is the name of this salt. What is the name of this salt? Sodium acetate. Okay. Next one. CH3COOH reacting with the calcium hydroxide. Calcium hydroxide. So which will form calcium acetate, CH3COO twice Ca plus we are going to get water. So that is what we can say calcium acetate. Okay. Next, fourth one, reaction with, this is the extremely important. Please note it. Very, very important. Everybody has to learn these equations. Reaction with carbonates and bicarbonates. Reaction with carbonates and bicarbonates. Okay. So that is only we will call it as a decarboxylation reaction. A very, very important reaction. Decarboxylation reaction. Okay. So when ethanoic acid reacts with metal carbonates and bicarbonates, so we are going to get, everybody, a brick effervescence will come. Brisk effervescence. Effervescence means what? What I said, effervescence means bubbles.
Carbon dioxide.
Yeah, bubbles will come. So due to release of CO2. So carbon dioxide gas. So this is the reactions which we used to call it as. Wherever we are getting, what is this reactions we used to call it as? Decarboxylation reactions. This is not the first time we are studying. Already we studied in metals and non-metals. So CH3COOH reacting with the sodium carbonate. Now, this both important equations. This is one of the tests to identifying ethanoic acid. So board exam also they asked many years this question. So CH3COONA plus water, and what is the brisk effervescence? Everybody. That is what we used to say, carbon dioxide. So learn it and write it. Very, very important equation. Again, I'm saying you. Next one. CH3COOH. Acetic acid reacting with the bicarbonate. What is the name of this component? Anybody can tell me? Common name. Common name. Second chapter we studied. Baking soda. Or we can say sodium hydrogen carbonate. Or we can say sodium. What is to say?
Bicarbonate.
Sodium bicarbonate. Sodium bicarbonate or sodium hydrogen carbonate. So which will gives us again same CH3COONA. My products are same. Only bicarbonate balancing equations only have to remember. So here balancing equations 2 CH3COOH and 2 CH3COONA. So what is the name of this one, everybody? Sodium
acetate.
Sodium acetate. This is also what is that? Sodium acetate. So remember, this is the one of the test to identifying ethanoic acid. So note that also. Test for one of the test for ethanoic acid. Ethanoic acid, that is what? Sodium hydrogen carbonate test. Either reacting with the bicarbonate or reacting with the hydrogen carbonate. So you can see whenever if you add this sodium hydrogen carbonate, so what will happen, everybody? It will produces what? A brisk effervescence. So then we can identify the given acid is a what? Anybody? The given organic substance is a what? Please respond. The given organic substance is the ethanoic acid. Okay. So now, for example, I will give you the two test tubes. Note it, everybody. Very, very important. So in that, one is alcohol is there, ethanol. One is alcohol and another one is ethanoic acid. We don't know. So it is A and B. So now one is alcohol and another one is what? One test tube, alcohol is there, organic compound. Another test tube, acid is there. That is what? Acetic acid. So acetic acid is there and here ethanol is there or ethyl alcohol. Now we want to identify. So how we can identify either it is ethanol or acetic acid? Anybody can tell? Or ethanoic acid? Ethanoic acid. What is the test we have to use it? Everybody. Please respond. That is the test name to identify ethanol and ethyl alcohol. Sorry, ethanoic acid. The test name, call it as a sodium hydrogen carbonate test. So sodium hydrogen carbonate test, what will happen? It will react only with what? Acid or alcohol? Anybody? It will react with what? React only with acid. So if it will react with acid, immediately we can notice some change. What is the change we can notice it? Everybody, please respond.
Brisk effervescence.
Yeah, brisk effervescence will come. That is what carbon dioxide gas will produce. Brisk effervescence. So it is indicating that we can notice the given test tube is ethanoic acid. Not only ethanoic acid, any carboxylic acid, we can use this test to identify. And suppose test tube A, if you are noticing brisk effervescence, then test tube B is a what? Alcohol. Test tube A is the acetic acid. Like that, you can identify the given substances, given organic acid, either it is alcohol or it is the carboxylic acid. We can identify it with sodium hydrogen carbonate test. That is why I said it is very, very important. Okay, ma? So next, second test, already which we studied here, litmus test. So litmus test, what will happen, everybody? If it is acid, means the given organic substance is acid, means it will convert into what? Blue litmus to which litmus? Red. So that is why this is the first test, actually, test number 1, which we used to call it as a litmus test. So organic substance is acid, means it will convert blue litmus to red litmus. But if you notice alcohol, what is the nature? Either it is acidic nature or basic nature or no reaction. Anybody? What is the nature of these alcohols? Everyone. Alcohols nature. Alcohols, what is the nature, amma? They won't show any reaction with the litmus because they are neither acidic nor basic in nature. So remember that, everybody. They will never show any reaction with the litmus paper. So that is what we will use. The first test to identifying ethanoic acid is the litmus test. Second test is ester test. We will study that. And third test is sodium hydrogen carbonate test. Okay. So this is the first, second and third reactions. So 3 properties we studied, or totally 4 we studied. Now the 5th and 6th property is very, very important. So please all of you write it. Reaction with the alcohol, that is only we can call it as reaction with alcohol. What is that name? Call it as, anybody can tell? Before reaction with the ethanoic acid came. Now reaction with alcohol, same equation. What is that name? Call it as esterification. So this is the second test to identify the given alcohol, given substance is the organic compound. It is a acetic acid or not. Esterification test. So what is happening? Esterification test. Ethanoic acid reacting with the ethanol. What will happen, everybody? Some smell will come. What is the smell? Ethanol. It will react with the ethanol. So under the presence of something, anybody can tell? Under the presence of something, what is that? Concentrated CH-4, and we have to warm it also. So then we'll get CH3, COO, C2H5. So what is the name of this one? Anybody? What is the name of this compound? I have taught you already. Ester is the functional group. That is the fruit smell. What is the name of this compound?
Ethyl ethanoic.
Yeah, ethyl acetate. You can write it. Ethyl acetate, or we can say ethyl ethanoate. So what is the functional group here? What is the smell? Ester. So ester means what smell will come? Sweet smell. Sweet smell will come, or fruity smell, or whatever it is, you can write. So this is what is actually. So please remember, esterification is the test to use it for both alcohols as well as what? Esterification is the test to use it for both alcohols as well as acids, carboxylic acids. So please write. Esterification is the test to the identify, use it to test the alcohols and carboxylic acid. So all the acids, carboxylic acid and alcohols, we can identify with the help of esterification, because both will react, then definitely they will produce the fruit smell. That is what ester smell, sweet smell will come. So we can say that. Okay. So this is what. But here, this equation book, it is wrong. So you have to change it and you have to modify it. You should learn very, very carefully. All of you do it that first. So esterification is the common test for identifying alcohols as well as carboxylic acids. Note it, everybody. Ethanoic acid. Yes. So this formula is wrong. All of you modify that formula. So I hope you can notice it here. I think the new book, it is corrected. Old book, this formula is wrong. So this is the formula. If you have an old book, you can see the formula is having mistake. If you're having a new book, this formula is correct only. So CH3COOH react with the CH3CH2OH. So it is a reversible reaction, indicating double. You can notice it. Reversible reactions. So we'll get CH3COOC2H5. Now here not one, it is a double bond. The typing mistake. C double bond O, single bond O, CH2, CH3. This CH2, CH3 only we can call it as a what? C2H5. And C double COO, CH3. So write the name. So they are putting common name as ester. So what is the name of this one, everybody? Ethyl acetate. Okay. So that is what you have to remember. Clear, everybody? Now, what is the use of it? Very important. Generally, esters are sweet smelling substances. So this is why, that is the reason we are used in making perfumes and flavoring agents. Note this. Very, very important. Use of esters. That is what is the use of this one? So esters means whatever the esters, they are sweet smelling substances. So these are used in making perfumes and flavoring agents. Now, on treating with the sodium hydroxide, which is an alkali, the ester is converted back to alcohol and the sodium salt of carboxylic acid. The reverse process, that is only call it as a saponification. Now we are going to study that. That is the last property. We are going to discuss that. So all of you note that. What is that? On treating with the sodium hydroxide, which is an alkali, the ester is converted back to sodium salt and carboxylic acid. Reverse reaction. That is only call it as, what is the name of this reaction, everybody? Reverse process of production of sodium alcohol. Call it as saponification. So actually it is used in preparation of soap. So soaps are sodium or potassium salts of long chain carboxylic acid. Definition of soap. Next, tomorrow's class we will discuss that. So all of you write that also. So soaps are sodium and potassium salts of long chain carboxylic acid. Now, one more thing I want to say. So esterification reaction, esters are most commonly formed by reaction of an acid and an alcohol. Ethanoic acid reacts with absolute ethanol. What do you mean by absolute ethanol? Anybody can tell? Absolute ethanol. We already studied absolute ethanol. Absolute ethanol. Please respond, everybody. What do you mean by absolute ethanol? Anyone? Pure.
Pure.
I'm saying when I'm teaching time, you are not listening means what we can do. So you can notice it here. Where is the ethanol? We have studied here. Yeah. Absolute alcohol. What is absolute alcohol? Even a small quantity of pure ethanol. Pure. No water is present or no other substances. A pure ethanol is called it as a absolute ethanol or absolute alcohol. So you have to learn that. So this ethanoic acid reacts with the what? Reacts with the absolute ethanol under the presence of a catalyst. Who is the catalyst here? Who is the catalyst? Anybody can tell? An acid catalyst. Who is that catalyst?
Sulfuric acid.
Sulfuric acid. Concentrated sulfuric acid. Write it. Concentrated sulfuric acid. Clear, Amma? So that is what it is now. So we are going to study the last property, that is what reverse reaction of it. So that is what we used to say. Reaction of this is not correct equation. So actually reacting with the sodium hydroxide, that is what we used to say saponification. The ester is converted back to alcohol and sodium salt of carboxylic acid when it is treating with the sodium hydroxide. That is what is an alkali. So that equation you write it. So and we have to heat it also, remember. So that is what we used to, what is the name of that equation, all of you? Sixth property, write it. Saponification. Saponification. If you have taken saponification, write it. CH3COO C2H5. What is the name of this one? Everybody. Ester. What is that ester name? Sodium. Sodium, sorry, ethyl. Ethyl acetate. So ethyl acetate treated with the what? Sodium hydroxide base, alkali. Then we'll get heat also, note it. We'll get again the salt, sodium acetate will come. CH3COOH, sorry, COONA. CH3COONA plus CH3CH2OH. That is only call it as a, what we used to call CH3CH2OH?
Ethanol.
Ethanol. Note it, everybody. So we'll get sodium acetate. Two reactions will be there. First reaction it is. So we'll get sodium acetate plus ethanol. Now, this sodium acetate, second reaction, write it here. This sodium acetate, CH3COONA, further reacting with the water. So we'll get again back. What is we'll get? CH3COOH plus NaOH will come. So this is what will happen. All of you note it. Okay, Mama? All of you understood? Everybody clear? So here they have written overall reaction. So that is you have to remember it. Okay, so again, what will happen? We will get sodium acetate plus we are going to get C2H5OH. What is that called it as? C2H5OH is called it as ethanol. Okay, ma? So ethanol plus sodium acetate will come. When this reaction of, what is that name called it as? Saponification reaction. So what exactly, sir, you are doing here? It is actually hydrolysis process. Note it, everybody. So hydrolysis of ester. Hydrolysis of ester in the presence of strong base. What is a strong base? Call it as alkali hydroxide. So it will form the sodium acetate plus ethanol. That is only call it as a saponification. So this saponification reaction, so we are using in manufacturing soap. So what is going to get soap reaction? Tomorrow we'll study that, but now I am saying you. So fat plus sodium reaction, NaOH, reacting with that, we are going to get a soap plus glycerol. So this is a common equation actually for saponification, manufacturing of soaps. What we are using, the body soaps and all, this is the chemical reaction. So here, soaps are basically salts of sodium. Sodium means Na, potassium means K. Salts of long chain carboxylic acids. So note it that, very, very important. Fat reacting with the sodium hydroxide. So on treating with the sodium hydroxide, what will happen? The ester is converted back to alcohol and sodium salt. Alcohol and sodium salt of carboxylic acid. Very, very important reaction. Now that sodium acetate will treated with the water. Again, we will get acetic acid plus NaOH. Reverse reaction. So that is what you have to remember. If sodium acetate is treated with the water, we will get acetic acid plus sodium hydroxide. If the this ester is treated with the base alkali, then we will get ethanol, alcohol plus sodium acetate. That is what you have to remember. So next, reaction with the bases already we studied. Like mineral acids, ethanoic acids react with the bases such as sodium hydroxide to give a salt. That is what sodium ethanoate, or commonly call it as a sodium acetate and water. So please write it. What is the common name, everybody? I already taught you. What is the name of that? Sodium ethanoate. Understanding? So sodium ethanoate or ethyl acetate. Sodium acetate we can say. So write it. Sodium ethanoate or sodium acetate. This is a common name. So the same sodium, if I put a ethyl, what is that call it as? If I strike the sodium and if I put ethyl ethanoate, that is call it as something. What is that call it as? Anybody? Ester. Ester. Okay. Or here also ethyl acetate. You can check it. The sweet smelling one, that is only call it as a ester. What is that actually? Ethyl acetate. Or we can say ethyl ethanoate. Same. Okay, va? Ellame clear? Please respond. Everybody? So now, from this I want to teach you, sir, what is ethanoate or acetate? CH3COO. This is what we used to call it as a ethanoate or acetate. If it is sodium ethanoate. If it is ethyl group, C2H5. What is the C2H5? What is the alkyl group name? C2H5 is a what group? What is the alkyl group? Ethyl alkyl group. C2H5 is a what group? Ethyl group. That is why it is ethyl acetate. Okay, clear, Harish? Mitakshri, anything doubt? So this is what we used to call it as. Alkyl group is ethyl. That is why it is called it as a ethyl acetate, or we can say ethyl ethanoate. So these are the 5 tests and we have to identify. And the second one is reaction with the bases. Of course, we have already done. We have already written it. You can check it. 3 acids, not only one base, one more base, calcium hydroxide also I have given. Last one is, how does ethanoic acid reacts with the carbonates and hydrogen carbonates? As I told you already, this is the test number 3 for identifying ethanoic acid or carboxylic acids. Okay. So what will happen, everybody? Even see, they are linking with chapter number 2, activity 2.5. So what is there in our NCERT? Chapter number 2, activity 2.5. You can check it. The same test we have to make it, and same arrangement we have to do it. Okay. So now what will happen, everybody? We can see a gas produced through freshly prepared lime water. So what do you observe? Anybody? The brick effervescence will come. That gas will pass through the lime water. Lime water means what? Calcium hydroxide. So which will turn up into something. What is that, anybody? Which will turn up into what? Carbon dioxide test, which will turn up into what? Milky. So milky means it is indicating what? What is that gas? If you pass that gas through the carbon calcium hydroxide, that gas is actually carbon dioxide. So that is what? Reaction with the carbonates and hydrogen carbonates. Ethanoic acid reacts with the carbonates and hydrogen carbonate to give rise a salt plus carbon dioxide and water. Most important one. And the salt produced is commonly called, what is the salt name? Sodium acetate, or we can say sodium ethoxate. Both are same. Okay. But is it alcohol will react with the sodium carbonate and sodium bicarbonate? No. No alcohol will react with the sodium carbonate and no reaction with alcohol. Only ethanoic acid or carboxylic acids will react. That is why this is the test to use it for identifying the carboxylic acid. So please note it. So this is what is about it. So very, very important. So up to here you all learn. Okay. Then soaps and detergents will leave it. So today offline class we are going to practice only this. Then soaps and detergents we will study. So soaps and detergents also extremely important. We will discuss that in the coming classes. Okay. Whenever time permits, we'll study that. But up to here is like 95% of 97% it is completed. Now only soaps and detergents. So from here also many activities are there. Every activity we have to make the conclusion. That's all. So it is over, means this chapter also completed. As I said, I finish. I finish. Now your duty is that how to study it. So how you will study is your choice. So for identifying ethanoic acid, how many tests are there? 3 tests. One is litmus test. Second one is what? Second one is what test? Ester test. And third one is sodium hydrogen carbonate test. Now, everyone you have to study that all the chemical properties. Chemical properties of alcohol, 5. Chemical properties of ethanoic acid, 6. Or constant acetic acid is 6. All the properties you have to study with the proper equations. Extremely important. If you study this, then I will wind up here. You can get back to the work and you can read, everybody. Then soaps and detergents will start at tomorrow's class. And then remaining thing we'll study, I think, this weekend. Okay. Thank you, everybody. We'll meet by 10 o'clock sharp.